Good evening, everyone. My name is Andrew Schutte, and I'm from SmoothLogics, and we're going to be talking about design intent. This will be a pretty fun discussion. The first time we've ever done anything like this at the West Michigan Lakeshore SolidWorks Users Group. Where the goal here is to really be more of a lecture, open discussion type theoretical discussion concept. We will certainly be in SolidWorks and try to bring some tangible realism to it. But the interesting thing with design intent is there's no right answer all of the time, so it's not like when this problem comes up, do it this way and you'll be golden. So my first slide here shows 6 different cubes. I've actually got 7 different ones drawn in SolidWorks. All of them are the same geometry. All of them do the same fit, form, and function. All of them would be manufactured the identical way. So from a geometric standpoint, the answer is consistent. From a SolidWorks design intent standpoint, what steps were taken to create these cubes and which way is the correct way based on your application. So that's kind of what we're going to talk about in a nutshell. Props to anybody who can think of more than 7 ways to design a cube. I did a few ways and then kept trying, like, oh, well, you could do it this way. Anyway, a little bit about me. This will all be online. You'll have the PowerPoint, so I'm not big on reading PowerPoint, so whoops, let's get past that. So here's what I'm really hoping, that we can all learn something. We can all challenge our own ideas and talk about our thoughts, comments, etc. Disclaimer, these are just my opinions, subject to personal experience, and any question you ever ask me, I'll always strive to give a logical answer instead of like, that's the way I've always done it, or, you know, it's the way I was told to once and I don't know. If I don't have one, call me out on it and we'll certainly talk about it, but that's at least my goal from a presentation standpoint. So quick little rant, and it kind of goes well into design intent. CAD, in my own opinion, is not computer-aided design. There's nothing aided about CAD, or there's nothing aided about design. CAD is simply a documentation tool. I'm sure we all know of phenomenal designers who can't even turn a computer on, right? Design is something that you conceptually come up with in your head. The computer does not create for you the table off input. You can't say, I need a circular device that's about 3 foot off the ground to hold my laptop. And the computer can't come up with that. You come up with that in your head, and you can document what you came up with on a computer via CAD. So I try to break this out into 3 Ds. We've got design, which happens in your head from a theoretic standpoint. Your document, which is in CAD, where we're going to model it. And then a detail, which is paper, traditional details, drawings that you send out to a machine shop or a fabrication facility. And each pillar is really dealt in isolation and has very little, if any, influence over another. And there's always exceptions, but these are generalistics. For example, whether I revolve this table, extrude this table, make this table out of surfacing, knit it all together, and form it out of a solid, how I document this in CAD has absolutely no bearing whatsoever on what I want this table to look like. What I want in my head has nothing to do with how I model it. Now, there might be limitations either in your skill of modeling in the CAD software itself, so you might always have some give and take when we come down to it. But what we think about in our head has no bearing whatsoever, whether it's SolidWorks, AutoCAD, Inventor, Creo, none of that matters. And likewise with detail, whether I extrude or revolve this tabletop, if I make a detail of it and it goes to manufacturing, go back to our blocks. No matter how I drew this block, the detail to manufacturing is identical. It's going to be a 3-sided cube of 1 inch each side. So it doesn't matter how it's created. The manufacturing segment, the detail segment of it itself, is going to be extremely consistent. So we really have 3 isolated areas, and this is where you can see some engineering departments. They have designers that can't run CAD. You have the CAD jockeys who model, and then you have the detailers that draw it. And I've never seen that to be a successful model. I'm certainly not encouraging anybody to embrace it, but you can see where it can be separated and how it is 3 different disciplines. I think the best users can do all 3 disciplines and can think about it end to end, but it is 3 distinct disciplines. So this is what I find interesting is anytime I ever talk about this, and I lecture about this at school a lot, I give a lot of user group and different technical presentations, and everybody gets so emotional. It's rather hilarious. But when you're like, you know, have you thought about doing it another way? For whatever reason, emotions get involved. But everyone has an opinion. Even if you don't, you do. There's no right answer all of the time. Although some answers are more right than others some of the time. It took me a while to come up with that. But application outcome is always key. At the end of the day, we need geometry. How we get that geometry is totally up to your discretion, but we want to get that geometry as good as possible, as intelligently as possible. And so here's some of my metrics for design intent. And at the end of the day, design intent always comes down to time savings, is kind of what I keep preaching. If you can do something faster, reliably, a different way, then that's probably your good design intent. When we always step back and say, what is design intent? It's either saving us time in the initial model, in modeling changes, which is really the big one for me. Design intent always comes down to when this changes, what happens. But, and I have an example later, but if you're given a detail print and just says, redraw this and export it into 3D CAD neutral dumb solid IGES, it doesn't matter how you hack that apart. You just need a dumb solid IGES at the end of the day. So there are always some exceptions. But then assembly functions, where you put your planes, your origins, etc. Detailing functions, manufacturing steps, or future readability. If I get hit by a bus, can the next designer pick up my stuff and figure out what I'm trying to do? So I think we're getting closer. I'm not going to read all these, but I tried to Google for a definition, and I got 3 different answers, the first, second link, and then Wikipedia. Further explanation, when I talk about design intent, I really don't like the idea because it's really not, again, SOLIDWORKS doesn't design. So what I really like to consider it is constructing the model in a way that naturally embraces the design parameters, is really how I like to think about it. So our discussion is wholly encapsulated in the document phase of our 3D pillars. And design intent is not influenced by manufacturing steps or processed. And then one of the exceptions there is sometimes in manufacturing you have to show like a rough casting or pre and post weld, etc. So sometimes we're constrained by manufacturing just from a step standpoint, but that's not certainly the 90% base case. And design intent is also not very important if the model never changes. So if you're literally given something and say, draw it, we're going to export this as a 3D solid and send it to China, then just hack out that model as fast as possible and send it off. If it's never guaranteed to change, you can be super sloppy. And I really only ever do that if I'm prototyping. I have a customer sitting over my shoulder, and it's easier to just draw another sketch, extrude a blob out, as opposed to go through my tree, figure out what to edit, and add that blob in an earlier sketch like would be proper. So I do very, very sloppy models, but it's almost always rapid prototyping, somebody staying over my shoulder, we're trying to prove something out, and then I 100% throw those away, build them up appropriately from the ground. Okay, so now we're actually getting to SOLIDWORKS, which is fun. I'll slow down a little bit. Here's my long-winded definition, part 1. When I lecture about design intent, it's always rules-based design. So if we look at this, you can kind of see there's relations on the screen. Let me try to focus that a little bit better. But you can kind of see there's relations on the screen, and all of that sketch geometry is black, which means it's fully defined. Now notice I have 4 total dimensions, yet I have 2 circles, a bunch of center lines, and a slot. All of this is intelligent rules-based design. You kind of see on the left-hand side there, circles are always the same diameter. So with a dimension, I'm going to define one circle, and the other one's going to be equal. Circles are aligned horizontally, so I have my horizontal or my center line with a horizontal relation. Vertically centered between the holes, there is a vertical slot. So I have center point of my center line, or origin in this instance, with vertical center lines going up to the bottom of my slot. The bottom of the slot is twice the circle diameter higher from the circle center line. So here I have, and I'll pull up the SOLIDWORKS model, but here I have a center line through the diameter of my circle, which is equal to 2 of these. So based on my rule of the design of what I need, this has to fit another part or a mating piece or whatever it might be, but I can create a rule with sketch geometry and relationships and say, from the center of the circles, in the middle, twice the diameter, the slot should start vertically. And all that can be accomplished without a single dimension added. And then the slot width is twice the circle diameter plus an 1/8 inch. So I have one center line here that's equal to the center line in my circle. And then I have my 1/8 inch, which is using the center line as my double dimension to generate that. So if my circle diameter ever changes, my slot width will change. So let's jump into SOLIDWORKS and actually see what this looks like. Give me a second to quick find this. All right, once we're here, we should stay here. If I can find it. There we go. All right, so here with our instant 2D, as Darren just showed us, if I change this to 5/8 of an inch, you can see my slot raised and got wider with a single dimensional change. And I can freely change this to quite a divergence, literally anything from 0.001 to 100. And all of this geometry is going to change accordingly. Now, if my rule says I need double the diameter plus a 1/16, I can change that there, and that will update accordingly. Now, the slot came down a little bit because my radius changed. But that's all based on my rules. Anybody have questions on it? Does that all follow? Yes, sir.
Why would you want to put rules in a sketch instead of a table? Things that I've heard in the past is keeping the sketch simpler is easier.
Yep.
I'm just curious, what is the comparison rules here compared to like the configuration class where you could do the same thing with tables? What is the benefit either way?
So the configuration class is specifically talking about the same type of geometry, many different variations of it. In this particular instance, I might only want one variation, but I know for sure because I work for Steve, and Steve never, ever thinks the same thing day in and day out. Steve, I know for a fact Steve's going to come up to me tomorrow and say, those dimensions should change. But based on the design intent of what Steve and I talked about before, I know that if the diameter changes, that slot also has to change. So to keep Steve happy, to keep doing a good job, I can change one dimension, the entire sketch rebuilds. I don't need to maintain the old version. I don't need to configure this at all. I'm just, the design is morphing and evolving as we go. So this is kind of an arbitrary example. I was trying to see how much crap I could fit in here in one little thing. This is not practical, I grant. And most of this discussion is not going to be go home and be super practical. We're very theoretical here as far as what we could accomplish with the tool of SolidWorks.
I think a simple way of saying it is to always pick relations when you can over dimensions. If you go back and change the whole, you would have to change it twice. Just use relations when you can. I guess I just don't understand where you have the 125. How'd you link that together with relations?
So the 125 is that this line here is the same as the diameter of the circle. Okay. So this slot is, half of the slot is the diameter of the circle plus 125.
I didn't see that you pointed to that. Thank you.
Yep, no problem. If you have any questions, just let me know. And Nathan is correct. You use relations as much as possible, but it's not an always rule. If I know for a fact that what Steve and I are working on, those two circles are the same now, but there's a high probability they're going to be different, or they're for two different applications, just happenstance that they're both a 1/2 inch, I don't want to link those. Because one's going to an air hose, the other one's going to an electrical cable. If one changes, I do not want the other one to change. So it's not an always or a never, it's a when it makes sense. And that's the frustrating thing about design intent, is it's a very difficult thing to lecture and talk about. Yeah, always, absolutely. So while I'm designing, here's just some of my thought process. From a base feature, what makes most sense? And I'm not going to read all of this, but as the model develops, we start asking ourselves radically different questions. In Darren's sketching class, he talked about he doesn't like sketch fillets, and I agree with him. I like feature fillets. The number one reason I dislike sketch fillets, they have their place, and I do use them. But the number one reason I like feature fillets is because you can have a single feature of a single radius filleting various geometry throughout your model. You're not constrained to a single 2D sketch plane. And so otherwise you have to do global variables and start linking dimensions, as opposed to being able to very simply edit a singular feature. And that's assuming you want the same radius fillet to be linked at various places throughout your model. So these are all different assumptions based on what you're trying to accomplish. But parent-child relationships is a good one, something to keep in mind. Rebuildability, if that's even a word, I'm not quite sure, and so on and so forth. So here's a couple specific examples, and we'll grab SolidWorks for this too as well. But what plane do you start on? And I'm a big advocate of this. If you're designing a car, a shoe, a machine, a gun, anything, it's usually in position. So if you're going to machine, or if you're going to model a plate of steel that gets bolted onto a machine and it's getting bolted down, top down, start modeling it on the top plane with the counterbore holes on top, so that when you put it into your machine, it's already in position and it mates much better. It helps the orientation of the prints and everything, is if everybody gets used to prints as the top plane or isometrics and all of that, it just blends in much better. And origin, I'm a big proponent of always having the origin center mass. You'll see that in all of our stuff. The center mass is always helpful because then you get instant planes for mirroring, instant origins for center relationships, etc., etc. Mirroring is awesome, but when possible, avoid using your mirrored sketch entities for sketch definition. And we will jump into this one in a minute because it's not the easiest to understand from reading. So here's an example where I want the same, and this actually isn't even a mirror. But we'll get there. So let's pretend that is a mirror. So I'm just going to select this rectangle and mirror that over. Now, I want to resist clicking on this entity and clicking on that one and typing in 4 inches. I don't believe that to be good design intent or a good usage of the sketch engine. And the reason is because if anything over here changes, what I want to be able to do is just right click here, select the entire mirror, delete it, and just remirror it. But if I have sketch relations going to that other side, I lose those dimensions as well. So what we ideally want to do is we always want to model our sketches on one side in total isolation. And I can do that by clicking the center line and moving the sketch to the other side, and it'll give me a double dimension. This is often used in like radiuses or revolves for your diameter versus your radius, but it works in every feature. Doesn't have to be just revolves. Anytime you pick any object and then pick a center line, it'll double your dimension based on what side of that center line you put your cursor. So I think the reason why I originally had this rectangle up here was so that I could show that. So I'll just make these equal again because I want these to be equal. And you can see here I have a dimension that's just hanging off into space, and a lot of people got confused why that's not touching there. And that's the example there, is I can double the dimension off the center line, and then I have complete symmetry here without relying on that symmetried geometry. Where if I ever have to delete it and recreate it, which I can do in like 3 clicks and 10 seconds, I don't have that constraint. None of my dimensions disappear. So that's mirroring. 3D sketches are awesome. It looks like I didn't finish my thought there, but they're a phenomenal tool for layouts and intelligent design, where you can say this has to be equal to that on an XYZ plane, 2 inches over from here. So you can do a 3D sketch first and then constrain a lot of geometry to it. And this is a little bit more rant, as you can see my disclaimer on the bottom, but sketch relations are your friend. If you can't see them, they're not helpful. The only time SOLIDWORKS shows you sketch relations is when you actually need them. Sketch relations are these little green boxes that turn orange and yellow and red and different things. But if your sketch relations aren't on your screen, they're not helping you. And SOLIDWORKS only shows your sketch relations while you're editing a sketch. So why would you ever turn them off in the only place where they're actually ever helpful? As soon as you build into your feature, they go away. So it's frustrating to me when a lot of people don't have sketch relations shown, and then I come over to help them with something, and I have no idea what's going on with their model, because you can figure out no design intent. You have no idea how everything could be fixed on the screen, literally fixed, and you'd have no idea. So the story of 7 1x1x1 blocks. What's the best method? And of course the answer is always, what are you trying to do? So let me open up all my blocks here a minute. So we won't go through all of these, but this one in particular, I drew a quarter of it, like so. And notice that I still have my 1 inch dimension. Because of my center line, I can draw a quarter of my block, make them equal to each other, draw my 1 inch dimension, and still, when I go to edit my feature, I'm prompted with 1 inch, because 1 inch is what's important to me, not a ½ inch, 1 inch. So with good design intent, I put on the dimensions that are going to be valuable in the model. And then I could pattern that around 4 times. And maybe I know I'm working on some type of a block, some type of a detail where I got to put holes in two sides or the top or something. And I can, at any time, I can roll that back, modify that first object, and pattern it around. So that's one example. Another example, some of these are pretty bizarre. Oh yeah, surfacing. So every single one of these, there's 6 of them here, every single surface was created in an individual feature with a knit and a form solid at the end. Still a 1x1 cube. If you hand it off to the machine shop, identical geometry, you'll get the exact same part. Just an absurd number of features for something so simple. But at any time, I can totally roll back and say, instead of this feature, I instead want to use something totally different. And I could modify our sketch and put in some sweep or loft, put a lofted surface in there instead. My knit will still work after I reselect my new surface, and I would get the exact same block with one side just totally organic, messed up geometry. So this could be really good design intent based on what you're trying to accomplish in the end. Here's another simple one where I just drew half of it and mirrored it. Same concept. Here's a fun one. I drew like 1/100th of it and then patterned it. It's possible, it is all what I'm trying to say. Here's a loft, because a loft between 2 identical profiles is really helpful. A sweep, so the profile in a single swept path. And I think our typical extrude. And even on this typical extrude, we want center origin, single dimension, and equal on our 2 sides, and then an extrude mid-plane to give us a center origin to our geometry. So even in a simple block, you can put in a significant amount of design intent based on what it is that you're trying to accomplish. So here's another great one, collinear or equal. If you had to draw this, would you want the 2 lines to be collinear, the horizontal lines, or the 2 vertical lines to be equal? You get the identical result at the end of the day. Some of the variations are, I actually don't know if I have this in Solver, so let me look. Some of this I just modeled and then deleted. Hey, look it. So here's the challenge. If Steve, based on the design, if Steve walks up to me, we'll pretend Steve's my boss, and he says, hey, Andrew, you know, that thing we worked on, we're going to make some changes. Based on what we're working on, what if one of those changes is like that? With good design intent, what should have my relations been? I totally should have made those equal, right? But what if Steve walks up to me and one of the changes is this? Well, that equal now has messed up that plane, and maybe these are always supposed to be in line. That's kind of where we go back to our rules-based geometry. What is it supposed to do? These 2 lines are always, is it critical to design that these 2 lines are always collinear, or is it critical that these 2 lines are always equal? You accomplish the same results, but what is it that we're after? What is our goal? And a lot of that will depend on what is the design, what are we trying to do, and if a change was to happen, where is the highest probability of that change to occur?
Wouldn't also the potential complexity of the design piece you're designing, because if it's something really simple, it really doesn't matter.
Yeah, certainly, and there's certain.
If you've got a block with lots of features.
Yep.
And what you're saying is critical, because if you anticipate changes or it's something that could be modified for multiple different projects.
Yep.
And what you're saying is critical because there's a lot going on.
Yeah.
For simple stuff like you've been showing us so far, it's.
But it's the thought process.
Right.
All we're trying to do is start thinking about it in a different way. There's all kinds of examples, and we will certainly get into more complicated stuff. But you are correct. When I go to start a plate, if I'm drawing a plate of steel for a machine, I don't go through 5 different questions in my head anymore. I pick the plane that it is in machine design, do a center point rectangle, grab my dimensions, do a mid-plane extrude, and I'm done. That's just the rule. I follow it, and it works really well. And then there's other things that I sit. My wife will comment because I do a lot of design at home, and I'll sit on the couch with my eyes closed, with my head look like I'm staring at the ceiling. And she's like, well, if you're really tired, you should go to bed. I'm like, no, dear, I'm thinking. You know, because what I'm trying to figure out is hard, and I'm designing in my head. Nobody designs on the computer. We design. Now, the computer is a great tool for design feedback. Is this going to work? Is this viable? Do I need to change it? And it's good for evaluation, where like, you know, is it going to handle my stress? Is that heavy enough material? Is that the right material? But the design happens in your head. So second one here, should this be equal or co-radial? Right? Now, if the requirement is the circle is always the same diameter, but it could move around, equal. If the requirement is the circle is always the same diameter and it's exactly in axial alignment, then what would it be? I'm sorry? Co-radial. Trick question. Convert entities. But yes, co-radial based on what is on the screen. But best design intent in this instance would be convert entities from Darren Grosser's. I mean, it would be anyway, but playing off what Darren Grosser was just showing us, convert entities would be your best optimal answer in that instance. There would be no reason to redraw that and go through the extra effort of saying co-radial. But yeah, I like trick questions. So here's a great example, and I use this in my class a lot, and we probably spend too much time on it. But here's where I also like sketch relations. Where is it? There it is. All right, so I need, and it doesn't matter how we made this slot, I don't want to go into it, but I need the identical keyway over here, all right? How would we go about doing so? Right, it's going to be in the middle, it's whatever, I mean, keyways are always square, so we get half of it, so this is an 1/8 inch by 1/4 inch. So I need an 1/8 inch by 1/4 inch keyway here. How would we go about doing that? You can't mirror it because it's not exactly parallel, it's up on an angle. So we're going to have to recreate it in a sketch in some capacity. Now most people would say, well, we need to cut into it, so I'm going to start a sketch on this side, draw my, and here we can do a center point rectangle because good design intent, we got our center origin, call this in 1/4 of an inch and cut down an 1/8 of an inch. Can't see my dialog boxes because they're hidden, but, right? That works for everybody, right? Okay, why is that not good design intent? In the beginning I said we want the same one as the one over here.
Just change one, you gotta go to the feature to change the other one.
Right, because if I change this from 1/4 to 375, this one ain't moving. So potentially a better way to think about, or a better way to handle this particular one, is I could start a sketch on, this side, like that. And now I all of a sudden have the ability to start constraining it to the first one. Now, yes, you could do these in the same feature. I'm not discounting that. You could have one feature to cut them both. I get that, but work with me here. And then we could certainly put this in the middle. And now, if one changes, and I didn't actually cut extrude that, but you can see that the other one is going to change just as well. Right? Everybody with me? All right. So let's pretend that this feature here doesn't exist. And we are creating our very own first keyway up here, and it has to be a 1/2 inch keyway, all right? Who knows how far we cut down into the model if it's a 1/2 inch keyway? I'm sorry? 250, right? Half of the 1/2 inch, right? Keys are square. I mean, you got tolerancing, I get that, but in an idealistic world. So we're gonna draw a rectangle, and now I'm gonna start doing math. And I don't like doing math. I mean, I love doing math, but every time I've challenged SOLIDWORKS to a math contest, SOLIDWORKS has always won. So there's no reason for me to ever do math when I have SOLIDWORKS as a tool. So the couple ways to fix this is we can say, you know what, I want to draw a center line there and make that collinear. And then I'm going to do my double dimension and say that's going to be a 1/2 inch. All right? But now I don't want to add another dimension that's also, not that way, that's also a 1/2 inch because 2 dimensions of each being a 1/2 inch is rather ridiculous. So somehow I got to tie these two together, but I have no 1/2 inch sketch entity in this axis to make equal to the other axis, right? You guys with me so far? So I would submit to you that the best solution in this particular instance is to double draw your keyway. We can pick our midpoint of our center line. We can pick the midpoint of our face, make these equal. Oh, parallel. Make those equal. Call out a singular dimension at a 1/2 inch. And it doesn't matter that the sketch is over our model. SOLIDWORKS can cut open space. Nothing matters. We can cut extrude this, and we have a perfect keyway. Now, the main advantage here is that if I pick on it and I change this dimension to 75, I not only get the proper width, I get the proper depth. Single dimension, intelligently driven keyway. I don't even have to have the machinist handbook memorized. And this is, we'll get to this later too, with other keys. But a lot of designers will pull out the machinist handbook and say, I have a 3/4 inch shaft, what keyway should be in there? Well, machinist handbook is all written on rules. Bruce, I'm sure you can tell us what the size of the key is supposed to be in relationship to the shaft. Yeah, it's always a quarter. So if it's a 1 inch shaft, 1/4 inch keyway. So there's a rule. It says 1 inch shaft, 1/4 inch keyway. 1 inch shaft, 1/4 inch keyway. So I should never have to come up with those dimensions, and we'll get to that later. But this is a really clever way to model a key, and a lot of people resist it because you're creating extra geometry in space that doesn't hurt anybody. And most people just focus, I need to remove a 1/2 inch by 1/4 inch, so that's what I should draw. But think about it a little bit broader. I'm putting in a keyway. A keyway is square. I don't want to have more dimensions than necessary, and I want single point edits. So I draw in my entire key and cut away that model. It's only going to cut away half of what I draw. Does that make sense to everyone? No? Pretty tired? Should have all grabbed a soda before we came out.
It's also easy to, if you use a center rectangle, if you got horizontal plane to pick a new point.
Right.
Quick.
But it's the concept that we're trying to get to.
Right.
So I'm going to have to keep speeding up to make our time, but stop me if you have any questions. All right, so here's the next design intent. How robust is this? Looking at the rest of our design, if anything else on this design changed, what are the statistical odds that that feature is going to error out? Anybody? Does anything jump out? Like, if I change the model, what's going to go wrong?
You zoom in on the relations.
Absolutely.
The vertical is going if you change the angle of the plate, that vertical line in the middle.
Excellent, Jake. Jake is correct. So here's the challenge. That cut extrude worked perfectly fine, but from a design intent standpoint, if this angle goes to 35, what went wrong?
The key is not square.
Right, but I put in the relation, I put in the parallel relation. Why is it not parallel? Because SolidWorks has determined that vertical carries more weight than parallel. So if we look back at our sketch, and we look at this, and well, I got to change this back now to 45. So if we look back at our sketch, we should be able to see all the relationships that are necessary and unnecessary. There is no reason for me to have this vertical relationship. And this is why it's extremely important to me, and what I stress to others is to show you relations. Because if you look at this, this could be a fixed, this could be perfectly defined, this could be horrifically defined. You have no idea. You cannot look at the design intent. You can't even evaluate how robust that feature will be if something changes if you can't see your relations. So now that I'm looking at my relations, I know in my head that everything I'm doing is on an angle. So if I'm modeling on an angle, there should be 0 horizontals and 0 verticals. So I want to be intentional about removing that vertical so that when Steve comes over to me and says, Andrew, that should really be 35 degrees, I can go like that, and the model rebuilds, it doesn't error out. Steve says, good job, Andrew, pats me on the back and leaves my cubicle, which is really my end goal. I want Steve to leave. That's what everybody wants. But design intent is critical to say, based on what changes, how is my current feature going to behave? And if I can improve the reliability, the robustness, the stability of that feature, then let's do that. And I have an example later where we want it to break, and it's an interesting dichotomy there. Sometimes we want it to break. So here's another great one. I was working with a company a while back, modeling a whole bunch of different parts for them. And one of them was, we did a whole bunch of shafts. And I was working with an individual, and both of us designed shafts radically different. You can see they're both in an assembly, and with our overlay here, within microns, they're identical geometry. Got splines, we got a keyway, we got different diameters. These are the same models. If I gave a print to a machine shop, I get the same part. But one of them is modeled with a revolve, which means I can control every diameter in a single sketch. And one of them, who wants to guess what they did? Oh, buddy, layer cakes. And this is really challenging because if this dimension changes, so this is a retention ring for a bearing or a sprocket. I think it's a sprocket actually. So a sprocket slides on here. There's your key, and there's your retention ring. So it doesn't slide off. So our design intent says we want our retention ring here to always, always, always be a 1/4 inch higher than that. That's our design intent. And even with the layer cakes, you can accomplish this. If this goes to 7, that retention ring grows with it. No problem, we're all on the same page. But then we have other problems with these other retention rings and stuff. And he actually did a pretty good job here. But the other things that we struggle with is if I want this surface to always be 1275 from that top, you can't do that with layer cakes very well. But in our revolve model, I can very easily grab, and this will overdefine it, but I can very easily grab this and say that's always there, and everything else is going to move. But the really cool thing about this model is the customer decided that a 1/4 inch radius, or 1/4 inch on the radius, or a 1/2 inch on the diameter, was the magical dimension for the retaining lip to hold our bearings and our sprockets. So in this instance, I define a 1/4 inch once, and I've got retention ledge, retention ledge, retention ledge. And I can slip on a couple bearings and a sprocket, and we're all good. If that's a problem, it needs to get bigger. All of those can get bigger. Nothing else changes. So good design intent. I intend to have a consistent lip to retain all of the circular bearings and sprockets and stuff I put on the shaft. And I can drive that with a single dimension with no other geometry changing at all. My stack-ups are the same, my assemblies are the same, everything's identical. And notice here as well, I only have 2 diameters called out. I have a singular diameter here that is collinear to this one, and I have another singular diameter. And they're both doubled over the center line to get your diameter dimension. I also have a singular dimension here, which is our bearing, which is equal to this landing here. And then I have a singular dimension for my sprocket. And we can see, not what I wanted, we can see on my PowerPoint how that pans out from a manufacturing print. The dimensions I put in the model have no bearing whatsoever on the dimensions I show on the print. I want to show on the print all of the diameters because that's what's important to the machinist. But as a CAD modeler, I only want to have the correct dimensions that drive design intent. And this is where collinear is a great example because I always want these bearing surfaces to be the same. So I would never want 2 dimensions in that instance. No worries. Down the stairs to the left, immediate left. So that's the tale of 2 shafts. Any questions at this time? Wow, no questions. That's either good or bad. We'll find out later. Another great shaft discussion. Let me see how many more slides I have. Oh, we're doing good. Might even be on time. Another great shaft discussion. We've all done keyways and shafts, right? This is a common thing, no contest. How do we go about doing this? Right? There's all kinds of ways, but just yell out one method. Extrude cut. All right. So, I'm sorry? I'm guessing that was a smart aleck comment from the smile. I didn't hear what you said, just from the smile. And we're clearly talking about in CAD, not in real life, so all that. All right, we want my first model. Sorry about that. Okay, so here's my first model. And this is what I see most common in the industry. This is in the SOLIDWORKS training manuals, the SOLIDWORKS handbooks, the YouTubes, everything online. You make your boss, you offset a plane, and you cut extrude down, right? It's really hard to argue with that. No, not what I wanted. It's really hard to argue with that. We've got a 3/8 keyway, which is half the depth down, so we have 3/16 cut down, and our inch wide, right? Who's done this? Who's seen this? This is just how you do keyways, right? Yes?
Yes.
All right, perfect. And again, we're not talking geometry. Geometry, every example we look at will be identical, so we're not talking geometry, just design intent. So I would submit to you that there's one easy step you can make to do this different, and that is to reduce features. If we're concerned about our number of features, we can always do an offset. Draw our sketch on one of our main planes, offset the cut extrude start, and then cut extrude through all. So in this instance, you have to do math, and I'm against math. As a person, I want the computer to do it for me. But here, you can say, we can do 7/16. I have my fraction decimal equivalents are not to memory.
437.5.
5/625. 16th over a half inch. 9/16. Yep, I'm sorry. 9/16 it is. So we have our 9/16 offset because I did math, but I don't want to do math. So we got rid of a feature, but we're still doing math, and we did math on this last one too. So math is the same, but at least we got rid of a feature. So if somebody's giving you feature tree metrics, you at least did a little bit better there. The next option. Okay, who's thought of this one? Making an extrude on the opposite plane and drawing the cross section of your key. So I know I need it to be inch 375 before my radiuses. And then I know this is going to be half of the width of my key. And then we can cut extrude the width of my key. Now, still math, still dimensions, I still don't like it, but it's an option. And then here you would have two full radius fillets. And the reason we do full radius fillets is because if this ever changes width, I don't have to update my fillets. Never want to update my fillets. My fillet is a full radius. If it goes from a 1/4 inch to an half inch, nobody cares. The problem is you just need two of them, which I'm not against features in the feature tree if they're good design intent logical features. All right, here's my method that I embrace and do when possible, when practical. Who wants to guess what it is? Anyone that's not been in my class? No, Whole Wizard does not. If you did a 3D Whole Wizard with you're still doing math. You're still doing math. No? Nobody? All right. So here's the method that I like. 0 dimensions. I hate dimensions. I hate dimensions when I can use rules-based geometry. And here's the thing. The machinist handbook dictates that the key is 1/4 the diameter of the shaft. If it's 1/4 the diameter of the shaft, I already have the geometry at my disposal necessary to define the size of my keyway. And in order to get 1/4 the diameter of the shaft, I can draw from the origin 2 center lines that are collinear, happen to be horizontal, and equal. This center line is now 1/4 the diameter of the shaft. I don't care what the diameter of the shaft is. I don't even have to commit to memory what keyway we use in shafts from an 1/8 inch up to, I think the machinist handbook goes to 10 inches or something. Then you get some odd different variance because it's removing too much material. But I don't even have to remember what all that crap is. Then I just draw a single vertical line to get my slot centered, have a rectangle with both sides equal, with midpoint coincident to the edge of my shaft, and cut extrude to my desired length with 2 fillets. So we have here literally, and I got to turn off instant 3D. We literally have here, if I can find them all, there's a dimension hidden there, but there's 3 dimensions for this part. There's the shaft width, the shaft diameter, or the shaft length, the shaft diameter, and how far of a keyway I want, 1 3/8 in this instance. There we go. Now they're all showing, sort of. No. Well, I think it's a graphics problem. Anyway, but 3 dimensions. You cannot pull this off with 3 dimensions in any other way. And again, the design intent is awesome because if this is now 2 inches, my shaft updated, my keyway updated. This is a 1/2 inch. It's still correct. No 0 dimension shaft keyway definition. Right? Who thinks that's cool, guys? That's pretty cool, right? Come on, give me something. All right. So here's a great example of when you want something to go wrong. Okay? I'm a firm believer, well, from a machine design standpoint, I'm a firm believer in using dowels for pretty much everything because I love dowels. Uh-oh. Sorry, that probably shouldn't have happened. Let's try that again. All right, so in this instance, it is possible to mate this block multiple different ways, right? We can all list a number of ways to mate it. I could mate it with planes, because I did good design intent, in my definition. Again, anytime I say this is, my definition, my experience. I could have done planes. I could have done a distance mate and said from here to there, I want you to be so far. Could have done lots of things. And if I had mated planes and faces, then no matter what I changed the holes to, it would always rebuild. It would never throw an error. But if this hole, I was going to talk about that too. So, real quick. 2 holes, a singular dimension. I want them in the middle, and I want them a ½ inch from the edge. Okay, 1 dimension, 2 holes. Because that's my design intent. How many dimensions do you think I have on my counterbore holes? And we look at the design intent, we still understand it's a ½ inch from the edge, centered, all that stuff. How many dimensions do I have, guys? 2, 1? Nathan says 0. Nathan knows me the best. I already have my ½ inch dimension. I know that my dowel hole is a ½ inch from the edge. That is my known value. Why would I ever rekey in that known value in a dimension? Never. There's no reason. Don't do it. All I have to do is draw a couple center lines, make a midpoint to the concentricity, however you say that word, and a couple lines that are equal. 0 dimensions. I'm following my design intent. Now, if my hole was to ever change, guess what happens to my pattern? Or guess what happens to my counterbores? Absolutely. Again, this is all assuming you want that behavior. If you want a different behavior, you do a different thing. But most of the time when I'm doing plates, I'm putting holes in the corner, it's for aesthetics and maximum strength and all of that kind of stuff. I usually want my holes in my corner anyway, so that's just what I get. And I pick a single spacing, and I always draw my dowels first because my dowels are my most critical aspect. If my dowels line up and my counterbores don't, the machinist can make slots, and it kind of looks like I wanted slots anyway. But if my dowels don't line up, we have problems. And you start bushing things, and it gets real ugly. But if I change that, I want it to blow up. If these mates still rebuilt, you've got a big problem. Because now you have a block that does not match its mating block. So in this instance, proper design intent, other than top-down design, you could use external relations. But proper design intent dictates that you will have errors in this assembly if those holes change. Because I did 2 concentric mates, my most critical dowel alignment holes, it said these 2 holes must always line up. If they never line up, I want to have an error. And if you did top-down design, they would follow along. I get all that, but it's not an option for everyone. Does that make sense to everybody? Again, the quietness bothers me. I don't know if you guys are deep in thought, ready to go to bed, counting down the minutes. We only got 10 more minutes. So here are my general rules. Center mass, constrain geometry intelligently. These are generals. Less dimensions better, not always, but general. Less features the better. Again, my keyway feature, I added 2 more fillets than I could have done in a slot in a sketch profile. But the design intent of putting that sketch on edge and drawing my key far outweighs adding 2 fillets, in my opinion. So these are just generalities. Leverage the use of the double dimension over center line. It's super helpful. Oh, offset. So this is a good one. I was doing a sheet metal project recently for somebody. And I stripped out all of the sensitive stuff, so this isn't giving away trade secrets or anything. But it's a sheet metal box with a sheet metal cover, right? Super simple. So my sheet metal box says it's 34 inches. My sheet metal cover, which is transparent here in case that was confusing, is 34 1/4. So who thinks I have a 1/4 inch gap or a 1/4 inch gap minus material thicknesses or whatever, right? So because of sheet metal, we always draw a single line and then add material of sheet metal on one side or the other. So on my lid, I wanted to add the material thickness on my edge flanges outside my material. So my driving dimension is an inside dimension. And you can see here too, I also used a mirror because there is certain geometry I didn't want to take the time to duplicate, so I just drew half of it, then mirrored it over. But if I measure the inside of these two lips, I get 34.25. So no matter what, and here's the design intent, I anticipate this material will change. Absolutely, I've changed it multiple times already. No, wrong button. So if I change this material from 18 gauge to 1/4 to be ridiculous, what's my inside dimension still going to be? 34.25. Because I added material to the outside, no matter what the material does, and I anticipate the material to change. My core critical dimension stays consistent. And the exact same, and if we go back to the model, I radically change this material thickness, but I am still going to maintain an 1/8 inch. Still going to maintain an 1/8 inch gap, which is necessary. And the same thing with this. If I change this from 34 to 34.25, and let's say I change my lid to 34.5, I know, and these are two different parts, so you could tie these again, but more external relationships, different discussion. I know that the 34, the dimension of my base plane here is always going to be consistent. Here's 34.25, and this is 34.25. Again, drew half of it, used my center line, mirrored it over. Because my edge flanges are, no, that's my mirror, because my edge flanges are material inside. So even the options you pick in your features will drive the intelligence of your model if you know what variable is likely to change. I know the sheet metal thickness, the gauge, is likely to change. So I'm going to construct my models around my known dimensions that I want to keep, and the material can do whatever the material wants to do. Make sense? Any questions? All right. I have a couple doozy examples at the end here. They're awesome. Because I didn't draw them and they're really terrible. Be mindful of material offsets. Use planes when mating if symmetry is important. So if we're drawing everything center mass, center origin, center everything, I put two items in somewhere and I know they have to be centered, use two planes. The planes will never go away. It'll be way more robust. And if the design intent is that the part is always in the middle, use your planes. There's always exceptions, but general. Control visibility. Like on purchase commodities, if it's some weird object and I have a plane that I often want to mate to, have that plane shown in your model so that in your assembly you can turn on planes that are visible, pick that one plane, and you don't get thousands of planes that show up. Drives me crazy. Hate it. Model stability, robustness is not everything. Having your model blow up when something goes wrong can be beneficial, as we talked about. I really dislike sitting through the lectures when they say, and if you do this, the model will never blow up. And I sat through one once where they're basically saying, use planes to mate everything. Don't ever use geometry because geometry is volatile, and then your assembly blows up. But I guarantee you that guy shipped parts to manufacturing that never fit because it never blew up on him, so the model was good. I guarantee it. I've met him. Met people like that, not that guy individual. All right, so I think I covered most of, oh, here's a great, so I was designing guns at home for fun because I like guns. And there's a lot of features here. I don't want to show you all of them, but if we look at how many features we have, there's 144 features. This is not really good design intent. This is still my prototype mode. So once I get done with what I want, I'll redesign it from scratch using good features. But point is, there's 144 features. And I got to my design at one point, and I realized I need this slide to be like an 1/8 inch longer. Thought to myself, oh crap. I have no idea how well I've honored design intent and where everything is constrained. If I make this longer, you know, is this casing ejection port going to get longer, or is it going to stay? You know, what's going to change? And mostly because I was lucky and because I think about design intent even in the background enough, it just tweaked that little bit and everything stayed exactly as it should be. I can change this down to 7. You can see just the end scooches in, or back scooches in. And all of the critical features constrained to one side or the other stay the same. I was pretty happy with myself. I was like, yeah, because I didn't expect it to be that good. So there's my last slide. Who wants to see really terrible examples? And these are out of the world. Nobody in this room did it. I got it from way out of state on some of my consulting gigs, so don't worry. Nobody here is going to be embarrassed. The first one I got here is a model. It's pretty hilarious. I meant to hide that. How many features should this take? Quickly going through your head. You got a revolve. You got a cut extrude around the perimeter, a couple holes, a couple cuts, a pattern. We've got 6, 8, 10, dozen, right? Not a big deal. Really simple. They got 39. Like, what do you do to get 39? And it's pretty hilarious. We'll walk through this one step by step. All right, start with the ring. Bad. Should have been a revolve. Added 1 hole. All right, yeah, 1 hole. So to pattern 3? Really? Just add 3 more holes. All right, cut all the way. Okay, yep, we're good. And do an extrude that does nothing because it's suppressed. I have no idea what it's supposed to do. Okay, add a ring. All right, yep. So we need a ring, add a ring, no big deal. But then what's the very next thing we do? Revolve the base, the bowl of this part. Then what's the very next thing we do? Cut away the middle. Like, come on, people, you're killing me. And then we extrude up a tube around the middle that we just cut away of what we just revolved. Like, really, people? And then we cut 1 slot and pattern it. What's the next thing we do? Cut 1 slot and pattern it. You couldn't make this stuff up. And then here, we cut another slot because we need a keyway or something. Add 1 more hole over to the right there. Okay, did you see that? That whole slot just got a little bit taller. Don't edit your old feature. Just keep scabbing on things. Okay, this is terrible. Like, I would be really mad if somebody gave me this model. Like, just make it, like if Steve brought me this model, said, Andrew, the designer that did this has left, but here's really good. All of his stuff worked. You just need to make a couple tweaks. I'd go back to Steve like a half an hour early and be like, yeah, I redrew it. All the assemblies are going to blow up for a little bit, but we'll fix them. But that model was a wreck. But that's just bad. And then does the same thing with the other ring. Come on. Add some more holes. So these they didn't bother to pattern, which I find funny. They didn't use a hole wizard, and they didn't bother patterning them. But they used a hole wizard and a pattern, circular pattern before. Then they added an extrude to flare out around those holes, fill it a bunch, and then remove that key. I'm sorry? So no, in their defense, this was actually over a couple years spread, and there was 3 different people working on it. But some of the features are the same guy within like 5 minutes of each other, like those circular patterns and stuff. So there's some give and take, and I'm not necessarily saying that this particular user is bad. I'm just demonstrating this is terrible design intent. And that's why design intent is so important. If you're scared to get in someone else's models, then either you're just really scared of other people's models, or the other person should have done it radically different. All right, got 2 more minutes. We'll breeze through this. How many features, guys? You got 1 sketch. This is sheet metal. So you got 1 sketch, to do your main extrude, a couple cuts on the end, a couple cuts for your slots, either an extrude here or a couple more cuts. But we're like what, 5, 6, 7, 4? There's a couple fillets. Right, not that many, right? Okay, who would believe 50? Who would believe 94? Okay, now there's another backstory to this too as well, but this is really funny, like funny. Okay, we start out with an extrude, which is a thin feature extrude without sheet metal. Then the very next thing we do is convert it to sheet metal, which adds radius. Like, really? Okay. Then we're going to do a cut extrude, and some of these are small, so if it doesn't pop out at you, we're not going to take the time to figure it out. But we're cutting stuff away, cutting stuff away, cutting stuff away, cutting stuff away. Oh yeah, it's good. We're having fun now. Yeah, there's some other cuts there on the edge. So I'm just going to breeze through this. Try to get, there's some good ones in here. Some more cuts. He likes lots of little cuts. So there's the boss with the tabs. Then we mirror it, okay? Oh, yeah. So we need a mirror, no problem. Cut away the old one, don't need that anymore. Do some more stuff, cuts. So here, we totally cut away the top. And then we add the top back on. Cut some, oh, mirror it back. Oh yeah, okay, delete the other part, don't need that. I can't make this up, okay? We're about halfway through. Some more extrudes, so like right here. extruded those bosses, extruded all that up, cut some more stuff off, cut it back. Okay, here's the best one. Unfold, fold. Some more cuts, some more extrudes. Unfold, cut, fold. All in the feature tree. Another mirror and another cut extrude. And ladies and gentlemen, we are finally done with, oops, not vent. We are finally done with our sheet metal part, which we can now flatten and send to the laser. Again, if Steve brought this to me and asked me to make some changes, I'd throw it out and redraw it in a heartbeat. So there's some info about me. If you have any questions at all, hang around. You guys have any questions now? What do you guys think? Give you something to think about? Wow.
Were sheet metal parts, if you go way back to 96 or 95, you didn't start with a form, did you just draw the blank and then
Yep.
put bend lines in?
Yeah, so sheet metal back in the day was done differently. I did forget I have one other sheet metal example here just as a quick, nope, not that. Squared around sheet metal example. So if I truly want to square it around, if it's all going to be in line, I only need a single dimension for my square. It's 12 inches square, it's 12 inches square, center origin, draw two lines to make them equal. I watched somebody do a squared around once and they added 2 dimensions here. I'm like, why? Why? If you want a 14-inch tomorrow, you have to change 2 dimensions and you have to do math. Don't do math. And same thing here. Single dimension, and again, what's important to me is diameter. So I'm going to put a diameter dimension on here, not a radius, because I don't want to do math, a diameter. And I'm going to use the construction geometry tree. I don't have a 90 degree here. I'm not defining this with dimensions. I'm constraining it to the existing sketch, which then gives me a square. So this is literally 3 dimensions, plane offset, and 2 sketch dimensions, squared around. While you got your material thickness. Any other questions?
Andrew uses me as a guinea pig. Obviously, I work here with him. We've done a lot of design intent stuff. And what we've done too with some of our engineers is we sit down with them and as a group and go over their designs. And it's not a criticize, it's not anything like that. It's say, hey, how'd you do a part? And it's just some ideas as other people throw out. You know, using center line, using planes, using an axis to draw a few things. You know, it's just a few things, tweaks here and there. That usually helps. And a lot of people aren't afraid to jump into somebody else's drawing because they do know how it's drawn. And it's drawn a little bit better than just maybe an average Joe or draftsman or something like that. So if you do have somebody to sit down with, hey, what do you think of my part? Would you do anything different? Nothing, you know, nothing critical or anything. What's your thoughts? You know, and it really helps us do a lot of design intent stuff, make our designs a little bit better, because our assemblies go a little bit better as well. So. But it's good stuff. Andrew's helped us out quite a bit here, and some of the guys really use it. So.
Any other questions or comments?